Welcome, dear logic world enthusiast. Today I built a very small unit which converts binary to decimal. I need this one for my CPU because this thing is doing whatever it wants and drawing lines between the wrong points. At least by now it draws lines, but the whole debugging process could have been a lot easier if I had these two displays here. The left one is showing me the program counter value and the right one the ALU output, both in decimal. And the good point is that it also supports negative numbers. So I don't even need to bother to look at the ALU output and convert it by myself in my head. I can just stay here at the bottom, this button, and just press it and see the values and compare that to whatever my debugging or test program outputs. And if the values match, perfect. So some have asked me if this really supports the range 127 to negative 128, and yeah, it does, with a small hack because of me thinking, well, so let's have a look at what's inside. So that you could build one for yourself probably. This will not be a tutorial, but I will eventually make a tutorial. Oh, what nice sounds Logic World is producing. This is on my server, by the way. I just reduced the chunk range for the video recording because I'm using a laptop. Okay, so the next target here is to take this apart. But let's tour it first. The input is at the front. The LSB is on this side and the MSB on this side. The MSB here represents the negative value of the input because I'm using signed bits, signed numbers, and this one is an 8-bit number because my computer happens to work with that. To take it apart, I need to move the displays a bit. So let's do that. Nice, here we go. This is the thing which we all love. Let's see, how can I get this where I want it? Front? Sounds good. Front. This is the point which you actually do not want to record. Okay, yeah, this is looking good. There we go. Perfect. Now it's been disconnecting some wires. I think the better solution would be to take this and grab it and just smash it on top here, like not so. There we go. This is the right way around. Which was the key? Yeah, this one. Cool. This one is broken. Let's get rid of it. And let's also grab this one and smash it on top. Oh, that sounds good. Looks good at least. Problem is, what is the key to move it? There we go. Perfect. Now I can take it apart with no worry. You might recognize things. I'm not sure if you have built like something like this before. Great deal. Oh, ouch, that noise when pressing undo. There will eventually be an update and things gonna be different. There we go. So currently my thing is to take this apart and show you the parts of this. As you can see, it's layers stacked on top of each other on a single mount each. And I can just simply take them, rotate them around, place them down, and then guess which side is the right one. Oh, did it catch my G key? Yeah, it did. There we go. Here comes the tricky part. Which one is the unit? Which is this one. Let's grab this and smash it around. Bam. By the way, this video is recorded in a freestyle manner, which is totally fine for its purpose, which is to just showcase this build. Now here you got all the layers smashed right behind each other, which gives you this beautiful pattern here where you have the diagonal modules. Let me align this properly so that you really can see the pattern. The algorithm is the same as everyone uses, which is the double one. Or, well, at least the algorithm is the same. However implemented is slightly different. But that's for a tutorial, which this video is not. This is not a tutorial, this is just a showcase of this unit here. Let's start front and continue to the back. So, I had this idea of a compact conversion unit, and this is it. What you can see here is a multiplexer at the end, which chooses either the original input, which gets piped here with some delayers, or alternatively the inverse of the number. The inverse is, as always, tooth complement. That means invert the number and increment it. The incrementation bit is this inverter here. This means constant +1. The inversion happens with the inverter over here. Yeah, so that is pretty much this thing. There's however a problem with this. If the input of this is 128, or if you look at this in signed number, this is -128. And the problem is that this unit here, the one which I built, outputs 0 at this point. But there's an overflow, which one cannot you might not be able to see. The overflow over here, right, it's this wire here. Oh boy, my computer starts lagging. That's not nice. Because this is 0, the display will show 0 if you have a -121, which is an edge case, which I handled by just smashing an extra bit here. This is a design failure, which I could fix by just drawing manual wires from this AND gate to the specific display units, and then it will work. Okay, as I said, this is double. That means we have the same unit here over and over. I have two versions of this unit. One is mirrored, the other one isn't, but else they are functionally the same. This thing, each of these purple units is doing decimal multiplication by 2 with a single digit. So you have the input values 1 or 0 to 9, which this thing multiplicates and outputs the numbers, encoded as binary or BCD, binary coded decimal. The other lines over here are basically just bypasses, which cause the whole display and converter to have no flickering, because you need everything to be synced. So every wire which just bypasses this unit goes through the 2 ticks which it takes. The same thing happens over here, multiplication by 2, multiplication by 2 again, and here we need 2 of the multiplication by 2 units, because you cannot always bypass the value, or this side, I don't know. Due to all the rotation, I lost overview and things MSB and LSB be jumping around, like on this unit it's on this side and here it's on the other side. Now that we converted the number into the binary number into its decimal digits, we just need to convert that to 7-segment display, which is done with another decoder. So we got basically just the inverter over there and the multiplexer and then a bunch of decoders. And here's the last decoder for the 7-segment display. And I didn't spare any cost, and that means you will have a leading 0, even if you just have a 1-digit number. Because why bother? I built this together in like 3 hours or something, so there's no prettiness in this. But it turned out much more compact than I originally intended to do. Like, one nice thing to make this even smaller would be to take each of these layers and smash it on the bottom side of this board, so that you have, I think it's 0.5 squares less of space of height usage, which would make the whole thing even smaller. And in general, one could optimize this like a lot more by just like not having these layers, but instead like smashing the decoders together somehow. But yeah, this is pretty much the whole unit, the whole thing, and I think there's nothing more to say. If you have questions, just ping me on Discord and I will gladly explain them. You can either leave a comment, and yeah, and eventually maybe you should bug me more. I will also make a tutorial on how to intuitively build binary to decimal converters, and maybe also the other way around, because there's not much different between decimal and binary conversion two ways. Yep, so I hope this helped you to get some insight about this display. And yeah, here you got a few numbers as whatever. Yeah, it will be enough for my display, my CPU. Amazing. Oh, totally not laggy. Oh, now it goes. Perfect. Works well, except that that's the wrong point in the line. It should be down here. Whatever. Eventually I'm gonna have this fixed. Have a nice day.